What's up, guys? Welcome to my class, Valeto Maths Academy. Here we make mathematics look very simple. Okay, we're diving into the course and we're starting with indices, understanding indices. Mathematics, everything we do revolves around numbers, and so it's ideal that we start the course with indices, or you can call it exponents. All right. So look at the objectives of this lecture. We'll define indices, understand and apply the laws of indices, solve problems involving indices, and understand the negative and fractional indices. And we'll also look at some simple mistakes and errors we make in indices. All right. So what are indices? An indices, or an index, or component, or like we locally call it power, tells you how many times to multiply a number by itself. All right. What we're trying to say is, for example, 2 raised to the power 3 is the same thing as 2 multiplied by 2 multiplied by 2, which is equal to 8. That is, 3 here is referred to as the exponent, or you can call it power, or you can call it the index. Okay, y2 here is the base. So the index tells you how many times to multiply the base by itself. Here 2 is the base, the index is 3. The index is saying multiply 2 by 2 3 times, which gives you 2 by 2 by 2, which is 2 times 2 times 2, which is 8. All right. So for another example, if you have 4 raised to the power 5, or 4, here 4 is the base and 5 is the exponent. So 4 raised to the power 5 is the same thing as 4 times 4 times 4, or 4 multiplied by 4 multiplied by 4 multiplied by 4. 1, 2, 3, 4, 5. One more. All right. That's the meaning of this. So that is what an index means. That is what an index tells you to do. Like I said that again, there are 2 major things you have to pick out from here: the exponent, or power, or index, and then the base. Okay, we move on. The general form of an index is a raised to the power n. If you do not like this annotation, you could also use x raised to the power a. All right, it's the same thing depending on the annotation you are conversant with. Okay, so what this means is you multiply here. A is the base, n is the index or exponent. Here x is the base and a is the exponent. So what this is telling us is that you multiply a by itself n number of times, or you multiply x by itself a number of times. In our example here, we have 3 raised to the power 4. This simply means you multiply 3 by itself 4 times, which is the same thing as 3 times 3 times 3 times 3. 4 times 3 times 3 is 9, times 3 is 27, times 3, 81. Here you have 5 raised to the power 2. Note that here 2 is the index and 5 is what? The base. And this is the same thing as 5 squared, which is the same thing as 5 times 5, and this is equal to what? 25. Okay, what if we have 2 raised to the power 4? This will now be 2 times 2 times 2 times 2 into 4 places. 1, 2, 3, 4. And this is the same thing as 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. You see it? That is as easy as ABC. All right, we move on. We talk of the laws of indices. You have the product rule, which I like to call the first law of indices. The product rule says that when you raise a base to an index and multiply it by the same base raised to another index, you can add both indexes on the base. Okay, let me break it down. If we use x, for instance, x raised to power a times, okay, here we are. If we use x, for instance, x raised to power a times x raised to power b is the same thing as x raised to power a plus b. So for example, if you say 2 raised to power 2 times 2 raised to power 3, this is the same thing as you pick the base. Since the bases are the same, you pick the base 2 raised to power the exponent plus the second exponent, 2 plus 3, and this is the same thing as 2 raised to power 5, and this is the same thing as 2 times 2 times 2 times 2, 1 2 3 4 times 2, 5, and the same thing as 2 times 2 4 times 2 8 times 2 16 times 2, I think that should be 32. Okay, if you get something different, please let me know in the comment section. Then if you're not comfortable using your brain or if you're not too fast with brain calculations, you can always use a calculator. Life is very easy these days. You don't have to stress yourself that much. All right, then we have the quotient rule, which I like to call the second law of indices, which has to do with division, quotient, division, product, multiplication. So the quotient rule says that if x raised to power a is divided by x raised to power b, this is the same thing as x. Since the bases are the same, you pick the base x and subtract the quotients and subtract the exponent. So if we take an example on this, we say 2 raised to power 3 divided by 2 raised to power 2. This is the same thing as 2 raised to power 3 minus 2. And this is the same thing as 2 raised to power 1. But in mathematics, we will not put 1 because we assume that every index is raised to power 1. Every base is raised to power 1. That is why it's multiplying itself one time. So that is why we don't have to write the power. Okay, so this is 2 raised to power 1, but we do not have to put a 1. Then we look at the next law of indices, which is the power of a power. It says that if x raised to power a is multiplied by another exponent b, it is the same thing as x raised to power a multiplied by b. Okay, please take note. So for example, 2 raised to power 2 raised to power 2 or raised to power 2 is the same thing as, okay, let's make this 3. It's the same thing as 2 raised to power 2 times 3. Note that this is very different from this. Note the difference between this, the first law, and this law. Note the difference between the product rule and the power of a power rule. Don't get it mixed up. When it's multiplication, you maintain the multiplication sign for the exponents. All right, we move on. If there's anything you're not clear about, you can always go back and watch the video again. If I'm speaking too slow, you can fast forward. We have technologies to do that now. If I'm speaking too fast for you, you can slow down the pace to your own pace. Okay. So this is 2 times 3 is 6. So this is something as 2 raised to the power 6, which is same thing as 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. One more, 6. And you can break that out to get what it is, which is 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64, something like that. If I'm wrong, please let me know in the comment section. Okay, we move on. More laws of indices. You have the power of a product's law. Here we can say where you have two different bases, all raised to a power, an exponent. It is the same thing as separating the bases, a raised to the power n multiplied by b raised to the power n. Okay, so if we use x like we have always used, x raised to the power x and y, for instance, raised to the power a will be the same thing as x raised to the power a times y raised to the power a. So if we take an example on this, we say example. Note that we are looking at example of the power of a product law. So we say 2 raised to the power 2 . Okay, let's make this a little complex. We say 4a all raised to the power 2. Yes, 4a all raised to the power 2. This is the same thing as 4 raised to the power 2 times a raised to the power 2. Okay? Yeah. In further classes, we'll learn how to simplify things like this. So if we have 2 raised to the power 2 times 3 raised to the power 2, what this is saying is the same thing as 2 times 3 all raised to the power 2. That is what the law is teaching us. So what it means here is that this is the same thing as 6 raised to the power 2. Okay? All right. And 6 raised to the power 2, remember this is the exponent and this is the base. You must keep this in your memory at all time. And this is the same thing as 6 times 6, not 6 times 2. Nope. 6 times 6. 6 raised to the power 2 is the same thing as 6 times 6. Remember the general form of indices, not 6 times 2, please. Okay? Then we have a law that says that anything raised to the power 0 is equal to 1. So if I have 1000 raised to the power 0, it is equal to 1. So long as the base is not equal to 0. So long as the base is not 0. 0 raised to the power 0 is not 1. 0 raised to the power 0 is 0. If there's anything like that. If you know better, you let me know. But anything raised to the power 0 is equal to 1. That's what we are teaching here today. Okay? At least for now, that is what mathematics says. Except things changes in the future, which is not likely to. Alright? Okay. Back to the lecture. We have the next law we'll talk about, which is the negative index. Under the negative index, we have, when you raise a power, when you raise a base to a negative exponent, it is simplified as follows. If we use x, for instance, x raised to power minus a is the same thing as 1 all over, convert this minus into 1 and make it a fraction, all over x raised to power a. It becomes easier to work with this fraction than to work with this. So if you have 5 raised to power minus 2, this is the same thing as 1 over 5 raised to power 2, which is the same thing as 1 all over what? 25. Very simple. Okay, we move on, no time. We look at fractional indices or fractional exponents. Here is where you need to pay more attention and try to follow as fast as you can. Now, if x raised to power 1 over n, note the difference. Negative indices is x raised to power minus n or minus a. It's different from fractional indices. We are raising the base to a negative, to a fraction. Here we have, to solve this is the same thing as the n roots of x, all raised to power a, and it's the same thing as the n roots of x raised to power a. Yes, these two are the same thing. If you use any of these formulas, you arrive at the same answer, hopefully. All right. Okay. So what I want to ask here, what I want to add here is, what about if the fraction is not so simple? Because here, what this means is x raised to power 1 over 2 is the same thing as the square root of x, and x raised to power 1 over 3 is the same thing as the cube root of x, and x raised to power 1 over 4 is the same thing as the fourth root of x. Are we in order? Okay. And x raised to power 1 over 5 is equal to the fifth root of x, and so on. Now, what about if the square root, if the numerator of the fraction, okay, what I was trying to say is, let's imagine, or let's assume that the numerator is not 1, because when it's 1, it's straightforward. So we call in English, say this is numerator, this is denominator in a fraction. Okay, so let's imagine that the numerator is something other than 1. Then what we're going to have is, for instance, x raised to power a over b. This is the same thing as the n root of x, all raised to power a. That's what I was trying to explain here. But if 1 is the numerator, then it's straightforward. But if 1 is not the numerator, then you have to apply this here. So n roots of x, all raised to power a, or is the same thing as x raised to power a. If then you look for the n root, you will arrive at absolutely the same answer, positively. Okay, so we take an example here. Um, 16 raised to power 1 over 2, which is the same thing as 6 raised to power half, is the same thing as the square root of 16, which is equal to 4. Then 27 raised to power 2 over 3. This is the same thing as 27 square. I find the cube root, and this is equals to 9. If you have your calculator, you can confirm what 27 square is. 27 square, it's 729, and the cube root of 729 is 9. We use the second formula. We'll say the cube root of, I always prefer using this because it makes, you can do it without calculator. The cube root of first equation, the cube root of 27 all raised to power 2. The denominator becomes the root and the numerator becomes the power. Okay, I always prefer using this format because it helps you to solve even without calculator, because using this format you have to square this first, and sometimes the numbers are so massive. 27 times 27, if you are not in a class where you are allowed to use calculator, it takes a lot of your time to do that. But here you can easily know that the cube root of 27 is what? 3. This is the same thing as 3 squared, and this is the same as 3 times 3. Remember, this is the exponent and this is the base, so the same as 3 times 3, and this equals to 9. So you see we arrived at the same answer. All right, we move on. Here you have worked examples to take a look at. This is the same thing as 2 raised to, this is for the first law, it's the same thing as 2 raised to power 3 plus 4, which is the same thing as 2 raised to power 7. And if you are to simplify this, it's the same thing as 5 divided by 5 raised to power 6 divided by 5 raised to power 2, and this is the same thing as 5 raised to power 6 minus 2, which is the same thing as 5 raised to power 4. And 5 raised to power 4 is the same thing as 5 times 5 times 5 times 5. 1, 2, 3, 4. Okay? And if you do that, that should be giving you 125 times 5. You should be having something like 360,625. Hold on, just to confirm. 5 times 5 is 25. 25 times 5 is 125 times 5 is 625. 625. Okay, 1, 2, 3, 4, not 5 times. Okay, 5 raised to power 4 is 625. All right. Okay. That's why sometimes it's necessary to use your calculator. Okay. You have another example here. All these examples, the solution you can find at the end of the slides. Here you have the worked example, solutions to worked examples. So if you make an attempt by yourself, you can always come back and see if you're right or if you're wrong. Okay, so these are the worked examples. We've done the first two. If we are to evaluate this, 3 raised to power 2 or raised to power 3, this is the same thing as 3 raised to power 2 times 3. Remember the law. 2 times 3 is 6. This is the same as 3 raised to the power 6, which you can further simplify and get the actual integer. Then, if you are to simplify 8 raised to the power 2 over 3, this is a fractional indices. So this is the same thing as the cube root of 8 all squared. The cube root of 8 here is 2 squared. So you can also simplify this as 2 times 2 times 2. You put your answer. Okay? Then we'll look at the common mistakes people made. Adding instead of multiplying in this law of indices. Remember, this is not addition. When you have this raised to an index multiplied by another index, you have to multiply. It is different from a raised to power x times a raised to power y. Here it's an addition rule. Here it is a raised to power x plus y. It is different from this, please. Do not make that mistake. It's an easy mistake people make in mathematics. And bear in mind, all these laws of indices are applied throughout mathematics. So wherever you find them, it doesn't have to be indices as a topic. Wherever you find any integer like this, or indices like this, or index like this, or exponents like this, apply the same law. It works for you perfectly fine. Okay? Then another common mistake we make is forgetting the negative index. And wherever you see this negative index, once you see the minus sign, just know that you have to put one above and raise it over a raised to power n. This helps you simplify the index. Okay? Then never you confuse or mistake a raised to power a fraction with a square. These are two different things. This is a raised to power half, which is this is the same thing as the square root of a, while this is the same thing as a times a square. Okay? All right, guys, you have some practice questions here. You can always pause the video, solve the practice question, and let me see your answers in the comment section. If you have attempted it, I want to see your answers. This class is for everybody. It doesn't matter if you're learning maths for the first time or if you have left maths for a very long time. Mathematics is good for everybody, keeps your mind active and makes you happy. Yeah. Okay. So first, to summarize, indices are shorthand for repeated multiplications. Index laws simplify algebraic expressions, and negative and fractional indices follow the same principle, absolutely the same principle. All right. Any doubt or concept you'd like to revisit, let me know. Any topic at all in mathematics. I'm a financial expert, but I'm very good with mathematics. So any topic at all you need in mathematics, please leave your comments in the page and I'll see how we can come to that. All right. You're advised to take a look at other lectures, and please like and subscribe this page so that whenever we release any topic on mathematics, you get notified as soon as possible. If you follow us on our page, follow us in our classes, I bet you in no time you'll become a guru in mathematics. Thank you for your time. See you in the next lecture.